Okay, so good morning, students. Okay, so in previous class we were discussing about the AC bridges and DC bridges. Okay, our second unit is nothing but AC bridges and DC bridges. So the bridges are used to measure the resistance value. Okay, capacitance, inductance values. Okay, the bridges which are used to find out the resistance value, those are called DC bridges. Okay, the bridges which are used to find out the inductance and capacitance value, those are called AC bridges. Okay, so in previous class we are discussing about the bridges are the DC bridges are classified according to the resistance value. Okay, here you have to divide the resistance into three types depending upon that range. Okay, that is low resistance, medium resistance, high resistance. Okay, the resistance which is less than 1 kilo ohm or is equal to the 1 kilo ohm, that resistance value will be called as low resistance. If the resistance is in between 1 ohm to 100 ohms, that resistance is called medium resistance. The resistance above 100 ohms, you have called that one is a high resistance. Okay, you have to see different bridges which are used for measurement of the resistance. So next you can see the AC bridges. AC bridges. Okay, in previous class we are discussing about the bridges which are used to find out the measurement of inductance. So in previous class, yesterday class we are discussing about the bridges. Okay, that is Maxwell's inductance bridge, Maxwell's inductance capacitance bridge, okay, Hayes bridge, Anderson bridge and Boyens bridge. So those are discussed in previous class as well as we are discussing about the capacitance bridges. What are the capacitance bridges? D.C&A.C bridge, Sharing bridge, Wien's bridge. The Wien's bridge is also used to find out the frequency value. Okay, so in previous class we are discussing up to D.C&A.C bridge. Okay, so now in this class we are discussing about the Sharing bridge. Okay, this is also one of the AC bridge to find out this is the Sharing bridge construction. Okay, this is also one of the bridge is used to find out the unknown capacitance value. Okay, see, and so any bridge, okay, so any bridge is formed by using the four arms. So here also AB, BC, CD, AD. Okay, by using these four arms, here you can form the sharing bridge. Okay, so in arm AB you have to connect the resistance C1 and internal resistance R1, and in arm BC you have to connect the resistor R3. Okay, so and in arm D you have to connect the C2. Here the unknown capacitance is C1. Okay, here you have to connect the unknown capacitance C1. Okay, so and in arm CD here you have to the parallel combination of variable capacitor and variable resistor. Okay, in previous class I think now 3 members will be joined. So in previous class I will discuss the inductance bridges. No one join the class, only Teja will join the class. In that class I will explain the inductance bridges. Okay, so one of the bridge D.C&A.C bridge is also discussed in a previous class. Madam, నేను చెప్తున్నాను మేడం, క్లాస్లోనే ఉన్నా. అవునా, ఏం మేడం? అవునా సరే సరే ఇప్పుడే స్టార్ట్ చేశాను మేడం 5 మినిట్స్ అయిందంటే 10:30 స్టార్ట్ చేశాను ఓకే 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 సో so in previous class I will say that those 5 bridges and one of the capacitance bridge D.C&A.C bridge. Okay, so in this class I will say that the sharing bridge. Okay, so see this sharing bridge consisting of 4 arms. So along AB you can assume the voltage drop in VE1. So along the BC you can assume the voltage drop will be E2. Along CD you can assume that voltage drop will be E4. Along AD you can assume that is the E3. In between 2 points A and C you have to give in the AC supply. Okay, so and in the points between B and D you have to connect the detector. Okay, the detector is used to find out the null deflection value. Okay, so and this is the phasor diagram for the sharing bridge. Okay, see here you can take the current I1, that is the current flows through E1. Okay, so E1 and the current flows to E2 will be I1. Okay, so next this will be E1 E2. Okay, and E1 E2 is equal to I2 by j omega C2. Why? Because here I1 and I2 you have to connect the which one you have to connect the capacitor. Okay, so this is the phasor diagram. Okay, so same. So what is the bridge balanced equation for the AC bridges? Z1 Z4 equal to Z2 Z3. Okay, Z1 means this one, Z2 means this one, Z3 means this one, Z4 means this one. So you have to write Z1 place in which Z1 place we are connecting which thing, and Z3 place we are connected what parameters, and Z2 place we are connected what is this. Okay, like this you have to place all one and you have to equating that one, you have to solve and equating real terms and equating previous class I will explain that in inductance bridges. So so you have to do the calculation by equating the real terms and imaginary terms. At that time you can get unknown capacitance. See, the bridge balance equation is for all bridges, all AC bridges, the bridge balance equation is Z1 Z4 Z2 Z3. So you have to write first that bridge balance equation and you have note down. So for different bridges these values will be changes. So in a sharing bridge, in Z1 place you are connecting in series with resistor and capacitor. So in D.C&A.C bridge another parameters like this. So you have to write that one, you have to substitute in the, so those Z1, Z2, Z3, Z4 substituted in this equation. By solving this equation, by equating real terms and imaginary terms, you can get the unknown capacitance which is to be find out. So see here Z1, Z2, Z3, Z4. Why? Because Z1 place, see in the diagram, Z1 place, here you have to connect the resistor in series with the capacitor. So resistor means R1, capacitor means you can write 1 by j omega C. So capacitance you can write in terms of 1 by j omega C. So so inductance, so here you can write in the terms of impedance form. Impedance form means R plus j omega X. Okay, so that's why here you can write R1 plus 1 by j omega C1. Z2 plus, here you have to connect only one capacitor. Okay, that's why here you can write 1 by j omega C2. In Z3 place you have to connect only the resistance value. So at that time here you can write the Z3 means R3, Z4 means, in Z4 place you have to connect the CD in the diagram. Z4 place you have to connect the resistor is in parallel with the capacitor. Okay, that means R4 is in parallel with C4. So at that time you can write R4 is in parallel with 1 by j omega C4. So at that time you have to substitute these all 4 values Z1, Z2, Z3, Z4 in this equation. So see, you can substitute and by solving by, so here you have real terms and imaginary terms. Imaginary terms means which are consisting of the j omega. So at that time whenever you have to equating that when you have equating real terms, at that time you have to get the unknown resistance R1 equal to R3 C4 by C2. Unknown capacitance. Okay, this sharing bridge is used to find out the unknown capacitance value. Okay, at that time this capacitance will be given by C1 equal to C2 of R4 by R3. Okay, so this is the sharing bridge. Okay, so this see, roughly you have to do that in notebook. In the Z1 place, you have to substitute this value. In Z2 place, you have to substitute this value. Z3 place R3, Z4 R4. So solving and equating real terms, imaginary terms, you will get these two equations. Okay. So in slide, this is not possible to do the total solving procedure. So that's why I have to write the directly. Okay, you have to practice in notebook. Okay, so so in material I have mentioned that one. Okay, so and from this you have to find the tan zeta. So zeta means angle. Okay, so angle W1 CR1 R1. In the R1 place you have to get R3 C4. By C2. So at that time you can write this value. C1 means C2 R4 by R3. As R1 means R3 C4 by C2. So at that time by solving this one, R3 will be cancelled, C2 will be cancelled. Finally you can get omega C for R4. Okay, this is the sharing bridge which is used to find out the measurement of the capacitance value. So next one is Wien's bridge. So the Wien's bridge is used to measurement of the Wien's bridge is used to the Wien's bridge is used to measure the frequency value. Okay, the frequency can be measured by the Wien's bridge as shown below. Okay, so the Wien's bridge is arranged in two ways. Okay, so either in this way you have to use or another in this way you have to use. Here also same. You have to write the bridge AC bridge balanced equation Z1 Z4 Z1 Z4 equal to Z2 Z3. So in which places you have to connect, write down. Okay, and finally solve them. See here. So here also same, the Wien's bridge is formed by 4 arms. Okay, AB, BC, CD, AD. Okay, so here also in the place of AB you have to connect the resistor in parallel with the capacitor. Okay, in place of BC here you have to connect the only resistor. In place of AD you have to connect the R2 C2. In place of CD you have to connect the R4. And you have to giving the supply voltage in between points A and C, and here you have to connect the null detector in between the points B and D. Okay, so here also B and okay, B and D. Okay, so here you have to internally you have to coupling this 2 1. Okay, this resistor and this one. Okay, so now here you have to write the bridge balance condition. Same Z1 Z4 equal to Z2 Z3. In Z1 place here you have to connect the parallel combination of R1 and C1. Okay, that's why you can write R1 parallel 1 by J omega C. So parallel combination means what is the any two one connected in parallel, what is the formula R1 R2 by R1 plus R2. So in R2 place here you have to 1 by J omega C1. That is you have to do that one. Okay, R1 R1 by J omega C1 by R1 plus 1 by J omega C1. So Z2 means R2 plus 1 by J omega C2. Z3 means R3. Z4 means R4. Okay, so by solving, okay, you have to substitute this equation and you have to solve this one. At that time you can get the you can equal the imaginary terms and real terms. Whenever you have to equal the real terms, so at that time you have to get the R4 R3 equal to R2 by R1 plus C1 by C2. Okay, so when you have to equal the imaginary terms, okay, when you have to equal the imaginary terms, so at that time you can get omega equal to 1 by square root of R1 plus R1 R2 C1 C2. So here I am says that here you can get the frequency value. Okay, by using the Wien's bridge. How to get the frequency value? See here omega means 2 pi f. Okay, whenever see you can write here 2 pi f. At the time 2 pi right this side, so at the time directly you can get f equal to 1 by 2 pi square root of R1 R2 C1 C2. Okay, this is the formula to find out the frequency value from the Okay, this is the formula to find out the unknown frequency value from by using the Wien's bridge. Okay, so in bridges, we have to discuss in previous class. We have to discussing the inductance bridges. Okay, the bridges which are used to find out the inductance values are Maxwell's inductance bridge, Maxwell's inductance capacitance bridge, Hayes bridge, Anderson bridge, Owens bridge. These are the 5 bridges is used to. Maxwell's inductance capacitance bridge is also used to find out the inductance as well as the capacitance value. Okay, these are the 5 bridges is used to find out the unknown inductance. Okay, the bridges which are used to find out the unknown capacitance are D.C&A.C bridge, sharing bridge. So by using the Wien's bridge also we have to find out the capacitance value. So Wien's bridge is also used to find out the frequency value. Okay, so up to now we have to discussing the total AC bridges. So remaining are DC bridges. We have to discussing the DC bridges. DC bridges means the DC bridges are used to find out the unknown resistance value. Okay, so you have to remaining one is DC bridges. Okay, we are discussing the DC bridges. Okay, so okay, so in previous two classes we are discussing about the DC bridges. DC bridges are nothing but these are used to find out the measurement of resistance. Okay, for measurement of low resistance we are using the Kelvin's double bridge. Okay, ammeter voltmeter method. So those are discussed in previous class. So remaining one is to measure the medium resistance, high resistance. Okay, see. Measurement of medium resistance means the resistance in between 1 ohm to 100 ohms. Okay, the resistance which lies between 1 ohm to 100 ohms, that resistance is called as the medium resistance. So the medium resistance can be measured by using the following methods. First one is ammeter voltmeter method, substitution method, Wheatstone bridge method. Okay, so here you can use the which bridge? The Wheatstone bridge. Okay, this is also very important. Okay, this is the one of the bridge is used to one of the bridge is used to find out the medium resistance value. Okay, so ammeter voltmeter method same. So in previous classes we are discussing about for measurement of low resistance the ammeter voltmeter method. So like this here also same. Okay, see first one is what? Ammeter voltmeter method is used to find out the measurement of the medium resistance. Okay, so here you can write ammeter voltmeter method. So first you have to connect the ammeter in series with resistor. So again here you connect the voltmeter. So first supply current IT will pass through IR, and here the current will be divided. Okay, so RX same here also IT. So V R. So here resistance means directly you can write V by I. Okay, so voltage source by the current flowing through the ammeter. So here you can write V by IR. I think here you can write V by IT. Okay, so that is the direct. So direct how to find out the resistance in circuits. So like this here also note down. Okay, so those are the formulas to find out the unknown resistance by using the ammeter voltmeter method. So next one is what? Substitution method. See, in substitution method here you have to find out the resistance. Okay, so see here R is the unknown resistance. Okay, this one is the unknown resistance and S is the standard variable resistance. Okay, this is the known resistance. Okay, so unknown resistance means the resistance which is to be find out. So here by using the substitution method, here you have to find out the which value? Resistance value. Okay, so here you have to connect the R. Okay, so here R is nothing but the unknown resistance value. Okay, in parallel with R, here you have to connect the S. S is nothing but variable resistance. That means known resistance value. A is the ammeter and R is the regulating resistance. That is nothing but rheostat. When you put the switch, here you have to use the switch. The switch having two buttons, 1 and 2. See, when you put the switch at position 2, whenever you have to put the switch at position 2, then R is connected in the circuit. At that time you have to connect the R. Okay, at that time the regulating resistance R is adjusted till the reading of ammeter at a chosen scale mark. Okay, so at that time you have to connect, you have to variable this rheostat. Okay, so at that time up to which value you want in the ammeter. So at that time you have to know the current value in the ammeter. So already you have to given the voltage value. Okay, supply voltage value E. So at that time you have to find out this unknown resistance. Unknown resistance is nothing but R equal to V by I. V means nothing but here E. So I means at that time whenever you have to vary the regulating resistance, at that time you have to get the current in the ammeter. So at that time you have to know voltage and current. At that time you have to find out the unknown resistance value. Okay, so that is the one. See, now this switch is thrown to position 1. Whenever this switch is in position 1, at that time the standard variable resistance S in the circuit. So at that time you have to connect the standard resistance. Okay, so at that time the now variable resistance S is adjusted till the reading of the same as when R was in the circuit. See, first here you have to connect the R. Okay, to find out R. So whenever you have connect the standard resistor also, at that time you have to vary the rheostat until the current in the ammeter is equal to previous one. Whenever you have connect the R in the circuit, at that time you can get how much of the current. So that current will comes to same to the resistor. So ammeter at that time you have to connect the regulating resistance. The setting of the dial of S is read. So the value of unknown resistance R is equal to the dial setting of the standard resistance. Okay, so that means whenever you have to get the same resistance of the previous one, so at that time you can note down the S value. Okay, so that is nothing but the unknown